Hello everyone, and welcome back to Sustainability and Engineering. Today's topic is something every HVAC engineer has heard about, but very few truly understand in practice. T1, T2, and T3. These three terms appear in almost every HVAC catalogs, yet they are also one of the biggest reasons systems fail in the Middle East. Not because of poor installation, not because of bad workmanship, but because the system was selected for the wrong design condition. By the end of the session, you will clearly understand what T1, T2, and T3 really mean, why UAE projects must use T3, and how to review HVAC submittals like a professional senior engineer, not a catalog reader. Let's start with why this topic actually matters. So let's start by understanding what are HVAC design conditions. Every HVAC system has one basic job: keep people comfortable no matter how harsh the outside conditions become. The problem is this: many systems are designed to look good on paper but fail when real summer conditions arrive. When design conditions are wrong, cooling complaints starts, electric bills increases, compressor trips, and equipment life reduces. So HVAC design conditions are not academic theory. They directly affect comfort, energy consumption, reliability, and client satisfaction. This is why we must understand what we are designing for, not just what we are installing. So basically, HVAC design conditions define the environmental limits under which the equipment must operate reliably. In simple terms, they answer one question: how bad can the weather get while the system is still expected to work properly? Design conditions usually include outdoor dry bulb temperature, outdoor wet bulb temperature, humidity. One very important point here: HVAC systems are never designed for average weather. They are designed for peak conditions, the worst realistic days of the year. Because if the system fails on those days, it fails when it matters the most. So let's understand what do we need to design for. Okay, we have to design the systems that could withstand during the peak summer conditions. In Middle East, usually the peak summer conditions are during the month of June and July. So during this time, we have to keep this worst case scenarios as a reference point and select the machines based on that. So if we design for average, the system looks efficient but collapses during summer peaks. So good HVAC engineering always designs for peak demand, not average comfort. This philosophy is the foundation behind T1, T2, and T3 ratings. Why T1, T2, and T3 ratings exist? So air conditioning manufacturers sell equipment globally. A unit used in Europe cannot be tested the same way as one used in Middle East. So rating categories were created to represent different climates, allow fair comparison, and protect compressor operating limits. This is very critical to understand. T1, T2, and T3 are not efficiency grades. They are climate operating categories. They describe whether the equipment can operate safely and not how good the equipment is. So talking about T1, which is moderate climate rating. T1 represents moderate climates. The standard outdoor temperature for T1 is 35 degrees Celsius. This is suitable for Europe, mild climates, and controlled environments. At 35 degrees Celsius, condenser pressure is low, compressor works comfortably, and efficiency looks excellent. This is why T1 equipment often looks very attractive on catalogs. In UAE or Middle East, the summer is not 35 degrees Celsius. When T1 rated equipment is used in UAE projects, capacity drops, compressors overload, power consumption increases, and failures occur earlier. This is not poor equipment. It is not wrong climate selection. T1 is not bad engineering. T1 is simply unsuitable for Middle East conditions. Now let's understand what is T2. T2 represents warm and humid climates. The design temperature is 46 degrees Celsius with higher humidity. T2 is typically used in tropical regions or coastal Southeast Asia. Compared to T1, T2 equipment handles heat better and is more robust. Now let's compare this to the Middle East reality. So tropical climate, it's hot. We all know that. But Middle East climate is hot and harsh. In Middle East, solar radiation is much higher. Condensers are often on rooftops. Units operate for longer continuous hours. So while T2 is an improvement over T1, it still does not fully represent Middle East conditions. Now let's understand what T3 means. T3 is usually represents extreme climate rating. T3 is designed specifically for extreme conditions. Yes, the temperature is still 46, but the testing philosophy is different. T3 considers desert conditions, high solar exposure, and sustained peak operations. This is what Middle East projects face. So why UAE projects must use T3? In UAE, ambient temperatures exceed more than 45 degrees Celsius. Units are usually exposed to direct sunlight, and HVAC runs 12 to 18 hours daily. This is why authorities insist performance on T3. If equipment is not T3 rated, it is already outside its safe operating envelope and it is effectively undersized by default. Now let's understand the impact of high ambient temperature. As outdoor temperature rises, it will affect condenser. As the condenser pressure increases, compressor discharge temperature rises, cooling capacity drops, and power consumption increases drastically. This is not a defect, this is basic thermodynamics. To understand capacity reduction reality, here is a simple reality check. A unit rated at 35 degrees Celsius will not deliver the same capacity at 46 degrees Celsius. That means a 1.5 ton unit can easily become 1.1 or 1.2 in real conditions. Ignoring this leads to cooling complaints, higher energy bills, and frequent breakdowns. Let me be very clear here. Most HVAC submittal rejections do not happen because contractors are careless. They happen because T1 catalogs are submitted for UAE projects, performance is quoted at 35 degrees, electrical loads are underestimated, and catalog footnotes are ignored. As engineers, our responsibility is to check rating conditions carefully, verify actual performance tables, and review compressor operating envelopes. Never ever approve equipment based on model numbers, sales brochures, or marketing claims. Engineering approval must always be based on verified performance data. Now let's go into a little bit more deep and understand how to check whether a HVAC unit is T1, T2 or T3 performance rated in simplest possible way. Going to step 1, you need to open the manufacturer data sheets from the submittal. Whatever you are reviewing or whatever you have submitted, go to the manufacturer data sheet, look for performance tables, look for cooling capacities, and look for power input. Step 2 would be reading the rating conditions. Okay, this is very important. In a small text or footnotes, you'll always find something like cooling capacity at outdoor conditions 35 degrees Celsius and cooling capacity at outdoor conditions 46 degrees Celsius. So 35 would be T1 and 46 would be T2 or T3. You need to check further. If the data sheets does not mention the outdoor temperature clearly, do not assume compliance. Okay. Now moving to step 3. You need to look for T3 explicitly mentioned in there. Okay, a true T3 compliant unit will clearly mention T3 rated, suitable for hot climate or Middle East conditions, or show performance tables at 46 degrees Celsius with stable capacity. If the catalog only shows values at 35 degrees Celsius, it is not suitable for Middle East, regardless of the brand. Now, let's understand this with a simple numerical example. Okay, suppose a contractor has submitted, or a supplier has submitted you a selection for 1.5 ton split AC unit. What contractor usually submits is the compliance to the cooling capacity, rating conditions, and power input. So suppose this cooling capacity is 1.5 ton, rating conditions are 35 degrees Celsius outdoor, and power input is 1.6 kilowatt. Looks perfect on paper. Now let's go to the reality check as per Middle East, that is 46 degrees outdoor ambient. When the same T1 rated unit operates at 46 degrees Celsius, the cooling capacity will be the first which will get affected. So if it is rated to work at 35 degrees Celsius T1, it's rated to work at 1.5 ton, the actual output would be not more than 1.1 or 1.2 ton in actual 46 degree T3 ambient. Okay, and the power consumption. So if this unit which has been proposed works at 1.6 kilowatt, it will consume more power to deliver the 1.1 or 1.2 at 46 degrees Celsius. Okay, and then third, the compressor load which will get affected. So now at T1, if the compressor is supposed to work at normal conditions, now it will be overloaded at high ambient. What does this cause basically? See, due to this, room will never reach its set point. Okay, AC runs continuously, which will turn into higher DIVA or SIVA bills. Compressor would trip on high pressures, and the equipment would fail very early. Like instead of failing at serving its life of 10 years, it would serve just 2 to 3 years, and that's it. This is not a equipment defect. This is not a wrong design condition. This is wrong design condition. This is actually wrong selection, you would say. So what would a T3 unit show? See, when correct T3 compliant data sheets are submitted to you, it will show cooling capacity declared at 46 degrees Celsius. Example, rated capacity of a unit 1.5 ton at 46 degrees Celsius will be clearly mentioned in the catalog or the data sheets. Power input is clearly stated. And the third thing you need to check, and that will be present in the compliant document, will be compressor operating envelopes, which will cover high ambient. This means you actually will get 1.5 ton in UAE summer or Middle East summer. System will run stable, energy use is predictable, and equipment will last its design life. If cooling capacity is quoted at 35 degrees Celsius, assume the unit will underperform in Middle East unless proven otherwise. Approval is not about trust, it is about verification. Basically, senior engineers should question assumptions, read footnotes carefully, approve based on data, not brochures or not verbal communications. Now let's conclude with these three simple but powerful points. 1. T1 is not bad engineering, it is bad climate selection. 2. T3 is not premium equipment, it is minimum requirement for Middle East projects. 3. Good HVAC design always respects climate, physics, and long-term system performance. Engineers don't fail projects, wrong assumptions do. If this session added value to your engineering knowledge, please like the video, share it with a fellow engineer, and subscribe to Sustainability and Engineering. Because every correct design decision we make today helps build better, safer, and more sustainable buildings tomorrow. Thank you for watching, and I'll see you in the next CPD session.